Okay, there's some link. Yeah, it works, I guess. Okay, so hi, my name is Martin Jeřábek, and today I'll be talking about some C++ features, quirks, weird stuff, interesting things that I've encountered in some past years and that surprised me, and hopefully we'll learn something from that stuff. And I want this to be interactive, so I'll be asking questions if you think it will work, compile, fail, and so on. And if you have any questions, so ask, interrupt me, and that. So we'll start with something simple. Let's parse some integers, unsigned integers. And yeah, we just want to have a function and feed it a string and get an unsigned integer. Simple. Is there any function in the C++ standard library that can do that?
It's in the libc A to E.
Okay. Yeah, I forgot to mention when it's not a number or the conversion fails, we want an exception, ideally.
You want what?
We want an exception, yeah. We want S to E. And why doesn't it click? Yeah, okay. We have S2UL, which is string to unsigned long, and it takes a string, returns unsigned long. We ignore the rest of the parameters because we want just base 10, and it throws exceptions. Invalid argument if no conversion can be performed, and out of range if the converted value is outside of the range. So yeah, that's nice. So let's try some examples. Yeah, we just feed it 1, 2, 3. What do you think it will return? 1, 2, 3. Okay, this one's easy. So what about this one?
Is it too big?
Yeah, maybe.
Platform dependent, I think.
Right. Okay.
Yeah, that's an easy answer.
Yeah, okay. You probably see the trick I did there because, yeah, we're on 64-bit platform and it just returns the number. Yeah, I didn't trick you. But I promise this one is bigger than 2 to the power of 64, so what will happen now?
I should run exception. It's also
Why is it platform dependent?
Because you don't know if unsigned long is on 128.
Right, but if it's 2 to the power of 32, it's still out of range, right? Yeah, okay, so yeah, if there was a platform which would have unsigned long to the power 128, yeah, that would work. But assuming we're on a platform where unsigned long is 64 bits, what should happen? Yeah. Exception, right. And we get an exception because it's out of range. Easy. So what about -1?
Exception.
some other exception.
Yeah, okay, exception, right? Except that no, we'll get this, which is 2 to the power of 64 minus 1 is just -1 cast to unsigned long because, yeah, makes complete sense. Yeah, okay. Let's try to feed it some garbage. What should happen now? Exception, right? Invalid argument, right? It's not a number, easy. What about this?
I suppose 123.
1, 2, 3.
1, 2, 3, no exception now.
No.
And
No.
maybe the return, something has to be.
Maybe both.
Both exception and 1, 2, 3 at the same time. Okay, I didn't expect that, but Okay, no, we get 1 to 3 because yeah, invalid argument only if no conversion could be performed, and yeah, clearly it can convert 1 to 3 because it's at the beginning of the string. So yeah, what about this garbage at the beginning? Exception. Any other thoughts? No, exception. Okay, and we'll get an exception. So yeah, what about this? Should be wrote the same, right? No? 1 to 3? Okay. How do you know that? It's 1 to 3. Because apparently, yeah, apparently we're ignoring leading white space because that's obvious, right? So
But maybe like leading white spaces are zeros and then like converts them to zeros and then 1 to 3.
yeah, but it's not a number, right? So
Yeah.
why does it? It's, I wouldn't expect a number conversion function to skip a leading white space or just partially parse or parse unsigned or signed integers as unsigned integers, but yeah, according to C++ standard devs, it makes perfect sense. And yeah, why do we get all this strange behavior? Let's look at the documentation of the function. Oh, then I was trying to do something quickly here, and I completely failed to do it quickly. But and I can still cannot read it on the display. So why does it do this stuff? It discards any white space characters until the first non-white space character is found. Okay, so it's in the description, and then takes as many characters to form a valid base n, unsigned integer number, and yeah, it consists of the valid unsigned integer value consists of the following: plus or minus sign for an unsigned integer. Makes sense, I guess, if you're a C++ standard person. And yeah, then there is, if the minus sign is part of the input sequence, then the output is as if negated by the unary minus, the result type, which applies unsigned integer wraparound rules. So yeah, it's codified, but why does it do that? I don't know. Doesn't seem very useful to me, but probably someone thought it's useful. So
Well, if you are parsing some kind of file and you have tab separated numbers, so you just parse it out, it stops parsing when the number ends, and then you just call it again on the rest, and you don't need anything else.
okay, so laziness is the reason, you say.
No, I mean, it saves you from some amount of overhead when you are parsing this.
Yeah,
And it
right.
usually does what you want. So
I'm not sure about that.
But like the whole thing seems pretty convenient to work with.
Yeah, it's convenient unless you're in a case that like the convenient is in a way. So yeah, that's the thing about convenient, smart, magically working things that yeah.
Well, you have
basically
exactly defined rules that you can read, and otherwise it's convenient. It usually does the most convenient thing you want. So like, well, let's do it. Is it convenient? Yeah. Is it clearly defined? Yeah.
Does it make sense? No.
Well,
But it's better than it's defined rather than less than defined.
Yeah, okay, that's true. That's the baseline. Better defined than undefined. Okay.
C++ is that rules are complicated.
Yeah, we'll see a lot of that.
The implications of these rules actually make things quite convenient to work with. Except that if you try to actually say, why should we do this? Well, then it gets complicated.
Yeah, let's move the discussion to the beer about convenience and sensible stuff. And okay, okay. So that was parsing. Okay. How do we make it just work as we want? In this case, just take a string, and if it's not a number, then error out. If it's negative number, error out. yeah, unfortunately, there is no standard library function that I found. It's possible that in C++ 10.26 or 29 there is, but yeah, in C++ 20 at least there is none. That is completely sane, but we can use from chars, which was added in C++ 20, and it just takes a string range and outputs an error code and puts the number in a variable. So another advantage is that you can precisely determine the type that you want to parse. It can be uint32, uint64, and it's no longer platform dependent. You have to check all the error codes, and you have to check that you parse the whole thing, and then you can return the number. So that's a sensible way to parse unsigned integers in C++. Yep. Okay. So another thing, now a little bit more arcane, is things with stud function. And we try to use it. And here is example of a code, a function which does something on a graph. It takes origin node, a mapping from one node to a list of nodes it points to, and counts all reachable nodes from the origin node. And because we want it to be flexible, the edges from is passed as a function, not just directly the vector of vectors, because it can be stored differently, it can be stored in nested structures, and so on. And the question is, assuming that the function is implemented correctly, what will this return? Or will it compile even? So that is the question. And if it isn't clear, the graph here is that node 0 points to node 1, node 1 points to just node 2, and node 2 doesn't point to anything. So what do you think should be or will be the result of this program or this function call?
Yeah, I should. I mean, I guess it should be nodes 2 and 3, but I don't understand why the function should return a const reference to a vector. Because it doesn't want to avoid copying.
Yeah.
But honestly, I would do it with stud span. Yeah, Nick.
Yeah, but the storage doesn't have to be contiguous. You can have.
You are
return
returning a vector which is automatic, which has to be contiguous. If you
Yeah.
use stud span, it's just more
Oh, okay.
and also
Yeah.
automatically reference
Right.
type.
Right, but in this case, we're returning const reference because, yeah.
Like my assumption was that like within the function, you actually need to construct the vector, fill it with the nodes, and then return the vector, which, I mean, it doesn't make sense to return a const reference to a local variable.
Yeah, that doesn't make sense, but yeah, the rationale is that the graph is somewhere constructed,
Yeah,
but
okay.
it's not like it doesn't have to be vector of vectors. It can be interspersed with some other data, or it's generic from some other reason. But this is what we have, the API, for the sake of the example, because that's what I came up with. Yeah, it's not ideal.
I suspect that you should have return type value for the lambda explicitly. The stack auto.
Yeah.
Otherwise,
Yeah.
you're trying to bind.
Yeah. Okay.
Sure it's going to compile at all.
Okay, I see you see the problem.
I have captured my reference.
Yeah, I'm capturing by reference. Okay, so first, what would be the correct result if everything worked?
I guess 2 and 3.
I
know 2.
Yeah.
1 and 2. Whatever.
yeah, for node 0, it should be 2, because there are 2 nodes reachable
I
from
thought
it.
because it is okay.
Yeah, but what we actually get is yeah, zigzag. It crashes, and yeah, why does it crash? Because yeah, I think you know why it crashes already. Let's look at the return type of the lambda. What is the return type of the lambda? It's auto, which means by value. But we want a function that returns a const reference to vector, and we have a function that returns by value, that returns the vector by value. And it shouldn't be possible, right? Because, yeah, why does it do that? And it turns out that stud function is covariant in its return type, which means that when we have this example, we have a base class and derived class derived from the base, and we want a stud function that returns point to base, and we instead give in function returning point to derived, we can do that. It automatically converts because it's convenient, right? You say, do you want convenient things? And this is convenient, but when you use it in a different way than it was intended, it bites you. And so what exactly happened is that the default return time of lambda is auto. That means it's by value, never by reference. And T is covariant with T const ref, which means you can convert value type to its constant reference. And when you do that, then basically you have a vector temporary which you take reference to, and it doesn't long enough, and basically you're returning reference to temporary, and it crashes because it's undefined behavior. So yeah, it's nice and convenient. And the solution obviously is to explicitly specify the return type either this way or used auto const ref or decl type auto. You know the difference between auto and decl type auto?
Like the auto is going to use the template type
Yeah.
reduction, so it's going to remove the red point stuff, and decl type is going to
Yeah.
take it.
Exactly. Decl type auto behaves like decl type, so it exactly takes the type of the return thing, but auto has the template argument semantics. Yeah, and raw function pointers don't behave this way. They're not covariant in the return type. So if you don't use more than C++ and use stud function, but function pointer, yeah, you'll not run into this problem. So yeah, it's just stud function being convenient. And I tried it in new GCC, and for some reason it refuses to compile this. It says it's an error. But when I tried with Clang and both standard libraries, it passed both times. So I don't think it's a standard library thing. It has to be GCC specific thing. But yeah, I didn't go into that more. If you have any idea.
What's the diagnostic GCC gives?
I think it says it just cannot convert that. I might, yeah, but it won't be shared. So okay, I'll do that later. And it says it cannot do the conversion because yeah, the types are not compatible. And MSVC warns that you're returning a reference to a local variable. So yeah. Okay, now a little fun things. Let's have some fun with templates. Let's have a template, and that takes a type by value, and if we assign to it, nothing happens on the outside because this is a copy. So if we do something like this, then at the end, x is still 0 and not 42. But the question is, can we do something like this? Is it valid? Is it legal? Does it compile? What will it do? Will the t be the reference? Or does this mean that we want a value type, so it will either forbid it or make it just int? What do you think?
I think it's unlawful.
Yes, I agree. It's unlawful. But it's C++. It doesn't care about our laws.
It's perfectly legal.
Yeah. Yeah. It compiles, it's perfectly legal. It does modify the variable, but yeah, if someone does that, it should be, it's unlawful and awful. So, some fun with pointers. Let's have some pointers, and yeah, we want to compare them. Are these operations valid? Does this compile?
Yes.
Both of them?
Yes.
Conditional.
Okay, yes, yes. And yeah, what about this? You want to assign 0 to p. Is that valid?
On 32-bit platforms, it could be valid because null is converted to pointer to integer, and they have the same 32-bit size.
No. It's well-defined operation. It is strictly defined operation.
Yeah.
It's defined.
Like the null defined from C is just 0.
Yeah, exactly. So yeah, this is perfectly valid because it just assigns null pointer to p, because 0 is, yeah, you said null in C is defined as 0. So yeah, what about these? Comparing with 0 or bigger than 0?
The first is invalid or conditionally valid.
It should be fine. First one should be fine, so
Yeah.
compared to null.
Okay, and the second one?
You're gonna say yes, but
The second is not.
Second is not, yeah. Okay, but yeah, like 0 is convertible to a pointer, because so why wouldn't the second one be all right? Yeah, it turns it isn't, but no idea why, because apparently 0 is sometimes convertible to pointer and sometimes it's not, because yeah, I don't know. I didn't go deep into this one because yeah.
I object this answer p equal to 0. There are some functions which can be more variadic functions which can be called with an attribute sentinel, and this attribute ensures at compile time that the last parameter of the function is null.
Right.
And if you write 0 instead of null, this is not the same.
Right, because
And then you have to convert the 0 to a void pointer. And in this context, 0 is not null, except on 32-bit platforms where both values are 32, have the same 32-bit size.
yeah, right. So 0 is not pointer, but it is convertible to a pointer, but apparently not when you compare pointer with 0.
Actually, do you mean the illegalness of this expression can be like by syntactic level or runtime, so to say? Because even if you used a static cast int star of 0, then it would be still illegal, because ordering comparisons are only applicable to pointers belonging to the same array.
Yeah, you're completely right. Then even this it's syntactically legal, but it might not be semantically legal, because if the pointers are not from the same array, it's illegal. It's I don't know if it's undefined or unspecified.
Undefined.
Undefined, okay.
So that means that if you try to just create some kind of black tree or some kind of tree structure to order some pointers, you don't care how they are ordered. You just
For this case, there is an std-less, which has explicit specification that it is legal to use on all the pointers. It's in the standard that std-less is exempt from this rule.
Exactly, that's step one of two that in STO specifically for algorithms that need to have their stuff, and even they need to work with pointers to void. So STD less actually can work with pointers to void. They don't have to be typed.
Yeah.
And basically,
But there's special rules just for less.
and I think the way it's implemented, you just cast the pointer to uint pointer t, because you can do that, and then it's a number, not a pointer, and you can compare the numbers. So, yeah, I think that's the way to legalize unrelated pointer comparison, or I don't know if there is some other magic in the std-less, but I doubt it. Okay, so fun with friends. Let's have this one thing, struct foo and private nested class with the friend function, which we implement later. Will this compile?
No.
No? Why?
Because at the point of definition of the frognicate, the name of nested is inaccessible. So frognicate could have access to the internals of the struct nested.
Yeah.
But in the first place, it cannot address the name of nested because it is private and free.
Yeah, exactly. Exactly, we just cannot do that. And yeah, the fix is easy. You have to be friends even with the parent class because the parent has to allow the child to be friends with you, apparently. And yeah.
And that's a nice sentence. Parent needs to allow
Yeah.
child to be friends with you.
Yeah. Easy fix, but can be a bit unexpected. So let's get overloaded. We just want to serialize some stuff, for example, JSON, it doesn't matter. Here we just have a few function overloads for bool, int, and string by string view. And yeah, let's just test it. What does this print? Serialize hello. Right? That's the sensible answer. And of course, it prints bool.
What?
Yeah.
Oh, converse the point.
It makes complete sense, right? Because, yeah, let's talk about overload, resolution, and implicit conversions. And we'll have to go into the standardized language a bit. And how C++ does that is because none of the overloads is exact match. So there has to be some conversion because this is basically something like pointer to const char. It's not really, but let's pretend it is. And yeah, how does it compare the conversion methods? So either it's exact match, which it is not, or it can do promotion, which is integer promotion, which is if you have types less than the size of int, it converts that to int. Or conversions. There are lots of conversions, numeric, integral, Boolean, user-defined, some stuff like that. And the standard conversion sequence is always better than a user-defined conversion sequence, which is important. And yeah, in standard conversion sequence, you have a lot of stuff. And that one which interests us is the numeric conversion, and a part of numeric conversion is the Boolean conversion, which says the PR value of integer floating point unscoped enumeration, pointer, etc. types can be converted to a PR value of type bool. So yeah, when you have a pointer, it can be converted. It's here. When you have a pointer, it can be converted to bool by Boolean conversion, which is a numeric conversion, which is a part of the standard conversion sequence. But if you want to convert it to a string view, it has to use a constructor call, and it's user-defined conversion, so it has lower priority than the conversion to bool. So yeah, we can have nice things. And yeah, the solution obviously is to introduce overload for const char pointer, and then it will work. So when we know this, which overload is selected here? If overloads with bool and int and have an unscoped enumeration. Or does it even compile? That's also the question.
Bool, of course.
Bool, okay. Does someone think it will be int?
I'm just gonna say it for the fun of it. So.
Okay, and you're right, it's int.
Didn't you say unscoped enumerations previously?
Yeah, I said that unscoped enumerations can be converted via bool conversion to bool. But yeah, we'll see with the next one. You have bool and unsigned instead of int, and the same enum. What will it do now?
Like if it were consistent, it would be unsigned again, but consistency is not.
Int is the default type, that's why.
Sorry?
Int is the default underlying type, that's why.
Which default?
Like default underlying type of an enum.
That's it.
It will compile.
Wait, is this like a promotion? It's like a conversion to int and then a promotion to unsigned. Or is this a conversion to bool?
Okay, so this one will not compile because it's ambiguous. Why is that? Because what's the underlying type of the enum? The default underlying type, if not specified, is int. So apparently enumerations can be converted to their underlying type, which is int. So in this case, it's then the exact match. But in this case, it's not an exact match. You can either convert it via numeric conversion to unsigned or via Boolean conversion to bool. And they are on the same rank, so it's ambiguous. Makes perfect sense. Yeah, and bonus, what is the type of hello exactly?
Const, char, and then
the brackets
the brackets, an array.
Okay, how long is the array?
6.
Right. Well, we have a way to tell the compiler to tell us the type. And we use template debugger, which is just a template class, which is not defined. And we try to declare a variable of this type with the thing we want to know the type of here. And the compiler will include the name in the error message. And yeah, it's const char array, but it's a reference to that. So yeah, that's the exact type of that. And this is very useful when you're debugging some long template instantiation bugs. It can be useful to just tell the compiler to print the type. And yeah, nowadays the compilers got loads of better in printing the error messages, but can still be quite useful. Okay, another bigger stuff. And yeah, this is a bit more involved. like we have a struct which is called key shape, and yeah, it's from a code where you work with like physical keys and logs, and the key has some shape, and it on some positions it has some cuts which are different levels of deep, and yeah, we just want to get a depth at some position of the key, and we're using a special type for depth, which is just integer shown in a new struct. And yeah, this is a way of strong numeric types. I could talk in detail about that sometime later, but it's just required for this example. And yeah, the basic idea is you can have different integer types like depth, key, position, and so on. And when you have special types, you cannot like intermix them, assign one to the other, so you don't confuse the types. Here it's just integer in a struct. And indexing operators, const one and non-const one. And yeah, because this is just a value type, we are returning by value because why not? It can be optimized, it's inline method, yeah, it's nice. So, and here, yeah, just a dummy array because I'm not gonna really implement it on a slide. So let's try to use it, right? We want to construct it, assign some depth into it, and print it. Will it work? Will it print 42 or will it miscompile? What do you think?
No.
It won't work?
No, it won't work.
Why?
Because you cannot assign to this MDEX from outside.
Why? It's struct, so it's public by default.
Yes, but MDEX is private.
Yeah, but you're implementing the indexing operator. I hope I did not forget to.
Okay.
Yeah. It's using the indexing operator.
Okay.
Is it like by default going to call the const version of this?
No, sorry. Yeah, this one will work. The first one always works. Okay, let's use it wrong. Let's try to assign to a const object.
Yeah.
It's the same code, we have a const shape, try to assign and print it. Will this work?
I mean, it's going to work, but it's not going to assign, because it's going to call the const overload. It's going to give you the copy of the depth instead of the reference.
Yeah, right. It compiles and it prints 42. But so operation failed successfully. But why? How can you assign to like a value type you written by value? So yeah, how can you assign to that? Apparently, there is a thing which is called yeah, okay. So the fix is just return const reference, and the problem disappears. But yeah, like this. And yeah, the thing is R value assignment, because apparently when you have R values, you can assign to them because why not? And you can prove that by let's have some tracker class which tracks which operator, what is the exact type of the instance on which the operator is called. Do that by overloading by this, and so it prints if it's on L value, const L value, R value, or const R value. We have functions returning by value, tracker and const tracker, and try to use that. And yeah, it will print that we're calling the assignment operator on R value reference and const R value reference. And this works even in C++ 2003, but it doesn't work in C. Obviously not with the operator overloading, but yeah, it doesn't fail and it doesn't work. So I said to myself, I won't give up that easily. I just want it to return depth by value, not by reference, because I won't be defeated that easily. So how can I make it fail? So I just delete the r-value assignment operator like this. Just delete the overload for r-value reference. And it works good. I have my depth by value and I'm really satisfied. But we have like a bunch of these record types, depth, key, position, which all derived from a common base. And I don't want to repeat that deleting in every of them, because when I forget that, I can use it wrong and there's problems. So I can just shove this into the base class and should work, right? Yeah, well, so let's have that, the base class, which has defaulted copy and move operators, because if we just delete it, then there would be also deleted. We want them. And delete the r-value overloads of the assignment operator, like we did before. And make a derived, which just derives from the base. And yeah, we're having functions returned in base and derived. Let's try that. With this error out, we are assigning to r-value of base. So will this work? Will this fail? Or if I was too fast or too unclear, don't fear to say it.
Should fail.
Okay. Yeah, it fails because we're using deleted function operator equals on the ref. If we tried it with the derived, will it also fail or will it work?
I mean, it could work if the derived doesn't by default call the assignment operator of the base.
I think it errors.
Okay, the derived is just yeah, it doesn't explicitly say anything about the assignments.
Yeah. So we do it.
Okay, nope.
Yeah.
It works.
Because you need to use the operator.
What?
You need to use the operator from the base class.
Yes.
But using
I mean, I guess
yeah.
the assignment operator of the derived it doesn't have to use the assignment operator base. Only the constructor has to call the constructor of the base.
Yeah, because the assignment operator, when not defined, it's defined implicitly. And so the compiler generates it for you, and it's implemented by calling the assignment operator of all bases and assignment operator for all members. And yeah, but we get this. And yeah, the question is why we do get this. We'd expect that to fail. And yeah, it calls the base operator assign, but for some reason, it's already an L value, and the compiler calls the operator on L value, because why not? And we can demonstrate that by, again, having tracker class, and that's the same as before, and having a derived tracker which inherits, and functions returning the derived tracker as non-const and const. And yeah, if we try that, then the first one, we already seen that it prints tracker ref, because we're using the r-value assignment operator. Second one, we're using the const ref assignment operator. But the third one, we get an L value reference. So yeah, apparently the derived implicitly defined assignment operator calls the L-value assignment on the base class. And the fourth one, it fails because it tries to call tracker constref assignment, and it's not defined for constref. So that one fails. Yeah, it's basically similar to this. And I think it's kind of a language defect because, yeah, I think it should call the assignment operator from the base class, the ref, but apparently nobody like uses this weird stuff. So yeah.
That's not true.
No, it's more like no one had a problem.
No one had a problem with that. Yeah. And yeah, if someone knows how to or where to like raise C++ bugs, I might do that. But so far, I saw that people write papers and post it to working groups, and I don't really want to do that. I don't want this that much because at that point I gave up. Just use the const reference and call it a day. So yeah. And yeah, the final one is C++ generation gap. We have a base class, which defines a protected method, derived, which uses the method, but it's private. And we want to test this derived class, so we want to expose the method publicly. So we do that, but we cannot do that from the derived because it's private. But the base, it's only protected, so can do that, right? Can we do that?
Can we do that?
Does it work? Does it compile? Does it not?
Derived,
I have no idea.
you will be derived from the one that is private. So
Yeah, but we're not using derived.
We're using base foo.
We're using base
that
foo.
should be fine.
But you have like two definitions of the same in the testing derived.
No, it's the same definition because it's just using the same function.
Just make everything public.
Yeah. Okay. Yeah. Okay. So who thinks it compiles?
I mean, it probably compiles since it's the first example, but I have no idea what happens.
Okay, so maybe one. Who thinks it doesn't compile? Also one. Two.
It shouldn't.
Okay, so the answer is come on.
Pay attention.
The answer is this.
Depends.
It depends. So you don't have to be ashamed that you didn't agree on the same opinion because the compilers cannot either. So yeah, it's fine.
So 2 to 1.
Sorry?
2 to 1.
2 to 1, yeah. I didn't try.
What's the error?
I think it's that I'm not sure. You cannot use the. Yeah, I don't know. I'll have to look at that.
I have the slides.
Yeah. Okay. So we'll look at that after I can deal with sharing a different window than this one. And yeah, so the summary is I love C++ because it's amazing, and you get to learn new things, new unexpected things, and it's fun. Life without it would be boring. Yeah. And it's not too much sarcastic. So yeah, that's all. That's the end. Thank you.
There was one question: what are the definitions when you show these three classes? It just appeared here on the screen somehow. I don't know how.
This?
Yeah, but the question appeared on the screen in the upper right corner.
No, I think the notification from
Yeah,
this
it was.
the-
Yeah, that was the notification
Can
from
you
the
go to slide number 8?
slide number 8. Hmm.
How to explain this? This was private within this context.
You mean this one?
Yes.
Okay.
How does v get a value if it's not passed as a pointer?
It's passed as a reference.
Okay.
Yeah. Okay.
Yeah, well, one thing I would would prefer here is that that you are criticizing that it doesn't tell clear, it's platform dependent what is the size of unsigned. And you just put unsigned here. It would be much nicer if you put there uint 32 or something like that.
Yeah, I agree. Because yeah, I just copied it and I want it to be, and it's not really the same time because here it's unsigned, before it was unsigned long, which can be the same length, but doesn't have to be. And even if they're the same length, they're not the same types. So yeah, okay. Should be uint 32t. So, sorry for that. Any other criticism? I can try to look at what's the error message of the last one.
No, it says that the foo is private within this context.
Yeah, right. Okay, yeah, it's not. Right. Oh, come on. Why does it not work? Yeah. This was private within this context because it's declared as foo in the parent. Yeah. Okay. So, any other questions? Okay. So I guess so. It was a bit faster than I